In this video on how to find a function's domain, we're going to be learning what to do when the function has a square root. So let's get started. You can see here that we have two functions. The first of which is f of x, which equals to the square root of 3x plus 12. And we need to find this function's domain. And for that, the important rule that we should always keep in mind is that any expression underneath a square root must be greater than or equal to 0. In other words, the expression underneath the square root can never be negative. So, to find this first function's domain, we need to make sure that 3x plus 12 is greater than or equal to 0. And we're now faced with an inequality that we need to solve. And with the exception of an important rule that we'll be seeing with the second example, we solve inequalities like this in exactly the same way that we solve equations. Here's what I mean. I'll start by getting rid of this 12 that's being added on the left-hand side, and to do that I subtract 12 from both sides of this inequality. That leads us to 3x is greater than or equal to negative 12. Now I want to get rid of this 3 that's multiplying x on the left-hand side, and for that I divide both sides of this inequality by 3. So that leads to x must be greater than or equal to negative 12 over 3. In other words, x must be greater than or equal to negative 4. Done. What we now have here is a condition for this function to be properly defined. Indeed, provided x is greater than or equal to negative 4, the expression 3x plus 12 will be greater than or equal to 0, which tells us that provided x is greater than or equal to negative 4, we'll never have anything negative underneath this square root, and our function will be well defined. And so we could state the function's domain like this, but we could also say that the domain is equal to all the numbers from negative 4 included up to positive infinity. Where this closed square bracket here means that negative 4 is included in the domain, since x is allowed to be greater than or equal to negative 4, and at positive infinity we always write an open bracket. And there we go. Now some of you may be used to writing the domain with brackets and parentheses, in which case you could write the domain is equal to the interval, which is closed at negative 4, which I indicate with a square bracket, and open-ended at positive infinity, which I indicate with a parentheses. Either one of these two notations should be accepted. Now before looking at the next example, let me quickly sketch the curve of f of x. So that would be the curve y equals to the square root of 3x plus 12. Now you can go ahead and check with your graphical calculators, but if you plot this curve, it should look something like this. We'll have an x and y grid, and the curve will start on the x-axis at negative 4, and then slowly increase as I go from left to right, something looking like this. There we go. Now looking at this curve, we can see quite clearly that the curve only starts at x equals to negative 4 and can only be seen for x values greater than negative 4. Indeed, there's nothing on the left-hand side here. And that further illustrates or highlights the fact that the domain consists of all the numbers that are greater than or equal to negative 4. That being said, I look at the second example. We have f of x, which equals to the square root of 10 minus 2x. And once again, we need to find this function's domain. Well, just as in the previous example, we need to make sure that 10 minus 2x is greater than or equal to 0. And so we go ahead and seek to solve 10 minus 2x greater than or equal to 0. Once more, I'm faced with an inequality that I have to solve, and to begin with, I'll get rid of this 10 on the left-hand side, which I do by subtracting 10 from both sides of the inequality. That leads us to negative 2x greater than or equal to negative 10. Next, I need to get rid of this negative 2, which is multiplying x on the left-hand side. And to do that, I'm going to divide both sides of this inequality by negative 2. But this is where we need to be careful. Anytime we multiply or divide both sides of an inequality by a negative number, we need to reverse the inequality symbol. So here, because we're dividing both sides by negative 2, this greater than or equal to will turn into a less than or equal to. And in fact, I'll put a little danger symbol right here to make a note of that. So because we're dividing both sides by negative 2, this inequality becomes x must be less than or equal to negative 10 over negative 2. And finally, x must be less than or equal to 5. And we're done. For this function to be well-defined, x must be less than or equal to 5. And so to indicate the domain, I could either stop there, but I could also write that the domain is equal to all real numbers from negative infinity up to 5 included, which I could also write as domain equals to all real numbers from negative infinity up to 5 included. Done. We've now found this function's domain. And so to finish this video, just as I did for the first example, I'll go ahead and sketch this function's curve. So that would be the curve y equals to the square root of 10 minus 2x. As always, you could check with your graphical calculator, but if you plot this curve, it should look something like this. We could start drawing the curve right here at 5 on the x-axis, and the curve slowly increases as we go from right to left, doing something like this. There we go. Looking at this graph, we can see quite clearly that the curve can only be seen for x values that are less than or equal to 5. Indeed, there is no curve or graph to be seen for x values greater than 5, which further confirms the domain we just found. And there we go. That's how we can find the domain of functions involving square roots. Remember, any expression underneath the root must be greater than or equal to 0. And there we go. That's it for this tutorial.